Hello friends, welcome back to my YouTube channel. So in today's video we will see a problem of unsymmetrical frame. So it is the L-shaped frame. So the given problem is analyze the frame shown in figure by flexibility method. So it is also called that force method or compatibility method. So this is our given frame. This is unsymmetrical frame. So both the ends are fixed here. So as usual our first step is to find out the ds degree of static indeterminacy. So for that we have the formula ds is equal to 3m plus r minus 3j minus capital R. So m is nothing but members. 3 into how many members? 1 into 2 members plus small r is nothing but the number of unknown reactions at fixed end. The number of unknown reactions are 3. Here also 3. 3 plus 3 6 minus 3 into how many joints are there? 1 2 3. So 3 into 3. So now simplify it. It will come out as 3. It will come out as 3. 3 means now the 3 numbers of redundants are there. So this structure is statically indeterminate. To make it statically determinate, we have to remove the 3 numbers of redundant in the structure. So I am selecting the support C. I'll release the fixed support at C and I'll consider SC and VC and MC as redundants. So I'll give the name. This is coordinate number 1, this is coordinate number 2 VC and the moment is coordinate number 3. So now I will redraw the diagram, the release structure of this frame. I will show by drawing. So after finding the redundant, first thing what we have to do is we need to redraw the diagram, and at each diagram we need to apply the only one coordinate. So I will show you. For this frame the 4 diagram will come. So this is the release structure of this frame. So it is called the capital M. So give it to the name A, B, C and A, B, C. This is our M1 moment of coordinate number 1, that is nothing but our SC. So at this is also A, B, C. This is M2 moment of coordinate number 2. This is M3 moment of coordinate number 3. So now give the name to all. So at each diagram we need to apply the at a time only one coordinate. So our first coordinate is SC. So we need to apply, it is horizontal, we need to apply. So it has the intensity of 1 kilonewton. At a time we need to apply only one coordinate. So M2 has the coordinate number 2, that is nothing but our vertical one. It also has the intensity of 1 kilonewton. So moment, it also has the intensity of 1 kilonewton. So this is how we need to draw, and we need to draw all the diagram. So for this we need to find the state. So put it here, UDL of 10 kilonewton per meter. This is our capital M diagram. So next is we need to draw the unit load table. So this is our unit load table. It has the member, origin, EI, limit, capital M, M1, M2, M3. So now, so see here. So now I am calculating from this side to this side. So again I am, as I told you earlier, I am skipping this calculation. To skip the calculation of this reaction, I am calculating from right side to left side. I am going anti-clockwise. So if you want to calculate this reaction, then you can calculate from left to right. You can calculate from here to here to clockwise you can go. So now I am going this side to this side to only skip this calculation part. So to save the time I am solving from right side to left side, this like anti-clockwise I will calculate. So we have the member CB and BA. So member is CB and BA. So for CB I am taking the origin as C, for BA I am taking the origin as B. EI for BA is I and EI for CB is I and BA is I. So EI is I. EI is I. 1 EI. I is nothing but. Limits is see here. CB has the length 3 meters. So our limits become 0 to 3, and BA has the length 4 meter. Our limit becomes 0 to 4. So now for capital M. For CB, if you cut the section x-axis away from the origin C at a distance of x, so here there is no load. For moment become for CB is 0 because it carries no load. Similarly for M1, so if you cut the section far away from the origin C, if you cut the section x-axis far away from the origin C at a distance of x, so for 1 kilonewton, at what distance it is acting from this section? From this section it is acting at a distance of x. So it is going upward. No, we need to take the positive. The sign convention you all know, which is going upward. We need to take the positive, and downward we need to take the negative. So it is going upward, so that we need to take the x. So positive x. Similarly for M2, if you cut the section M2 for portion for member CB, we have the origin C. If you cut the section x-axis far away from the origin C at a distance of x, so 1 kilonewton is acting axially to this member, so our moment becomes 0. So M2 becomes 0. Similarly for M3, so if you cut the section x-axis far away from the origin C at a distance of x, so this 1 kilonewton is acting clockwise, but we should not see that whether it is acting clockwise or anti-clockwise. We have to see that. So what is the effect of this 1 kilonewton on this member? So it is pushing the member to downward, so we need to take the -1. So downward means we need to take the negative. So we have the value M1. See here, I will show. So like this is the member. The 1 kilonewton is the clockwise like this. So it is pushing this member to downward. Downward means it has a negative effect on this member, so that the value is -1 into the value is -1. So M3 value is -1. Similarly for BA, so origin we have taken B, and for M1, for M we need to see, if we cut the section x-axis far away from the origin B at a distance of x, our M becomes, so here UDL is acting, no, so it if you convert UDL to point load, it acts downward like this. Downward means we need to take the negative, so it acts like this. So minus into UDL is having the load of 10 kilonewton at a distance of x. From here to here is x. So UDL usually acts at the distance of L by 2. L by 2 is nothing but our x is here. X, our distance is x known. L by 2 is nothing but x divided by 2. So solve it. 2 1 ja 2 5 ja, it comes -5 into x square. -5 x square is our M value for the BA member. The value is -5 x square. -5 x square. Similarly for M1, if you cut the section x-axis far away from the origin B at a distance of x, so our 1 kilonewton, so what is the perpendicular distance of 1 kilonewton is this one. So this BC is perpendicular to 1 kilonewton. BC has the length of 3 meter. So our M1 becomes 3. So it is going upward. No, upward means we need to take the positive. So the value becomes 3. M1 value becomes 3. Similarly for M2, if you cut the section x-axis at the distance of x from the origin B, so 1 kilonewton. So at what distance it is acting from here to here is x. At a distance of x it is acting. So our M2 becomes x. So it is going upward. No, we need to take the positive x. Similarly for our M3, if you cut the section like this at a distance of x from the origin B. So it comes, we have already known the moment transformation, so it is acting here, no? So when it comes to at point B, here it acts like this, and here it acts like this, here it acts like this. So at point B, if you cut the section like this, so moment here comes like this, no? Like this means it is also acting downward. So it has the negative effect on this member. So we need to take the again -1. The moment will be same. For M3 we have the value -1. So this is how we need to fill all the values. So I hope you all are understood. So our next is to find the flexibility matrix. So our matrix becomes here 3 into 3. We have the coordinate 3, no? So our matrix becomes 3 into 3. So flexibility matrix is equal to F11, F12, F13, F21, F22, F23, F31, F32, F33. So we need to now find all the values. So now I will show. So for F11 we have the formula integration of 0 to L m1 square divided by EI into dx is equal to, so 1 divided by EI is constant, I am taking it outside. So now integration of m1, we need to see all the member. For CB we have the m1 value x, and for BA we have the m1 value 3. So for CB we have the limit 0 to 3. So integration of 0 to 3 into x square dx plus for BA we have the limit 0 to 4. Integration of 0 to 4, the value is 3 square dx. So now solve it. So integration of 0 to 3 into x square plus integration of 0 to 4 into 3 square. So now solve it. Our F11 value will come out as 45. So F11 value is 45 divided by EI. Similarly for F12 is equal to F21. For both we have the same formula for both the value. So integration of 0 to L, here we need to multiply the moment of first point, here also moment of first point. Here first point is 1, now we need to multiply m1, and here first point is 2, now we need to take the m2. So moment of m1 and m2 divided by EI into dx. So 1 divided by EI is constant, I am taking it outside. So now integration of m1 and m2 we need to see. For CB, m1 is x, we need to multiply this into this. So here 0 is there, so 0 into anything becomes 0, so I am not taking it. For BA we have the value 3 into x, this into this, and limit we have 0 to 4. So 0 to 4 into 3 into x dx. So now solve it. Integration of 0 to 4 into 3x. So solve it. It will come out as 24. F12 value will come out as 24 divided by EI. Similarly for F13 and F31 we need to calculate. So F13 is equal to F31 is equal to integration of 0 to L. Here first point is 1, so M1. Here first point is 3, so M2 moment of coordinate number 3 divided by EI into dx is equal to 1 divided by EI, I am taking outside. So integration of m1 and m3 we need to see. So m1 is x and m3 is -1. This into this one and this into this one. For CB we have the limit 0 to 3. So integration of 0 to 3. So m1 is x and m3 is -1 dx plus, for BA we have the limit 0 to 4. Integration of 0 to 4 and this into this one, 3 into -1. So 3 into minus 1 into dx. So now solve it. Integration of 0 to 3 into x into minus 1 is nothing but minus x. So minus x dx plus integration of 0 to 4. Integration of 0 to 4 into 3 into minus 1 is nothing but minus 3. So now solve it. Our f13 and 31 value will come out as minus 16.5. So write it here, minus 16.5 divided by EI. Similarly for F23 and F32 we have the formula F23 is equal to F32 is equal to integration of 0 to L. First point is 2. So moment of coordinate number 2 into moment of coordinate number 3, M3 divided by EI into dx is equal to 1 divided by EI outside. So integration of this into this one becomes 0. For CB 0 into anything becomes 0. I am not taking it, and this into this one is minus x. So your limit is 0 to 4. Integration of 0 to 4 minus x into dx. So solve it. Integration of 0 to 4 into minus x into minus x. So it will come out as minus 8. F23 value is minus 8 divided by EI. Similarly, we need to find the F22 and F33. For F22, integration of 0 to L m2 square divided by EI into dx. So 1 divided by EI I am taking outside. Integration of now m2 is, so m2 for CB is 0 and m2 for BA is x. So we have the limit 0 to 4. So integration of 0 to 4 into x square dx. So now solve it by using calci. So integration of 0 to 4 into x square. So solve it. Our F22 value will come out as 21.33. 21.33 divided by EI. Similarly for F33 we have the formula integration of 0 to L m3 square divided by EI into dx is equal to 1 divided by EI. So integration of m3 is for CB is minus 1, for BA is minus 1. So integration of 0 to 3 into minus 1 whole square dx plus integration of 0 to 4 minus 1 whole square dx. So now solve it. Integration of 0 to 3 into minus 1 square plus integration of 0 to 4 into minus 1 square. So now solve it. Our F33 will come out as 7. F33 is 7 divided by EI. So now we got all the value. So write it here. F11 value we got was 45 and F12 value we got was 24 and F21 value also 24. F13 value we got was minus 16.5 similarly, and F31 value also minus 16.5. F22 value we got was 21.33. so write it here 21.33, and F23 value we got was minus 8. F32 value also minus 8. F33 value we got was 7. So put it here, divided by 1 divided by EI. So this is our flexibility matrix. So now from compatibility equation, P matrix is equal to flexibility matrix, inverse of it into dou matrix minus displacement matrix. So this matrix becomes 0 dou matrix. The value is yielding value is not given, and dl is nothing but our displacement matrix. So we have the three number of redundant. Now we need to find the, so for redundant one we need to find the d1 and d2 and d3. As many redundant, we need to take the that numbers of dl matrix. d1 d2 d3 we need to find. So for d1 again, so for d1 we have the formula integration of 0 to L capital M into small m1 divided by EI into dx. So 1 divided by EI I am taking outside. So now integration of capital N and small m1. So capital M is 0. So 0 into anything becomes 0. And for BA we have the m value minus 5x square and m1 is 3. This into this we need to do. Limit is 0 to 4. So limit is 0 to 4 minus 5x square into 3. So m is minus 5x square minus 5x square into 3. So into 3 dx. So now solve it. Integration of 0 to 4 into minus 5x square into 3. So now solve it. Our d1 value will come out as minus 320. So d1 value is equal to minus 320 divided by EI. Similarly for d2 we have the formula integration of 0 to L capital M into m2. Here for d2 we have to take the moment of coordinate number 2 divided by EI into dx is equal to 1 divided by EI. So now integration of m into m2. So here m is 0, 0 into here also 0, 0 into 0 becomes 0. So for BA this into this one minus 5x square into x square is nothing but minus 5x cube. So limit is 0 to 4. So limit is 0 to 4 minus 5x cube dx. So by using calci we'll solve it. So I am writing here only, make it x cube x to the power of 3. So now solve it. It will come out as minus 320. For d2 also is minus 320 divided by EI. The value is same. Similarly for d3 we have the formula integration of 0 to L capital M into small m3 divided by EI into dx is equal to 1 divided by EI. So integration of capital M into m3 is nothing but capital M is 0. This into this becomes 0. For BA minus 5x square into minus 1. This into this it becomes 5x square. So 5x square integration of limit is 0 to 4. Integration of 0 to 4 5x square into dx. So now solve it. So I will write it here only. This is 5x square. So 5x square. So x to the power of 2 5x square. So now solve it. Our d3 value will come out as 106.66 is nothing but 106.67. d3 value is 106.67 divided by EI. So now we got the this DL displacement matrix. Now fill all the values here in this matrix. So P is nothing but our whatever the coordinate we have taken. So whatever the coordinate we have taken, this one coordinate number 1 2 3. So for P I am writing the for P matrix I am writing the coordinate number value we assumed was horizontal one, so HC, and coordinate 2 we have taken VC, and for coordinate number 3 we have taken MC moment. So our P matrix is nothing but whatever the redundant we have released, we need to take those values here. Flexibility matrix, so we need to write all the value. So 45, 25 minus 16.5, 24, 21.33 minus 8 minus 16.5 minus 8 and 7 inverse of it. So and into, so this into minus of DL matrix. So minus of our DL matrix is nothing but the whatever the value we have calculated. D1 value is minus 320, so minus 320. D2 is also minus 320, D2 also minus 320, and D3 is 106.67. so close the matrix. So now solve it by using calci. We need to calculate this one. So I have already shown how to calculate this. So go to, so mode matrix is at number 6 now, so we need to press here 6, and here you can see all the matrix. Mat A is at number 1 now, we need to press the 1 here, so 1. So our matrix 1 is 3 into 3 now, 3 into 3 is at number 1. Again press the number 1 here, so press number 1. So now the 3 into 3 matrix came. So now substitute put all these values. The value is 45. 45 is equal to 24 is equal to minus 16.5 is equal to 24 is equal to 21.33 is equal to minus 8 is equal to minus 16.5 is equal to minus 8 is equal to 7 equal to. So now after filling we need to press this AC1. So now go to shift and again press the number 4. So here at number 2 you can see the data, so go inside the data, so press number 2, and now you can see the matrix B at number 2. So press the 2 here, so press the 2 here, and the matrix B is 3 into 1 matrix, so 3 into 1 is at number 3, so press 3 here, press 3 here. So now enter all the value. So minus 320 is equal to minus 320 and 106.67. So now again press AC here, go to shift and again press number 4. So now you could see the matrix is at number 3 now, so press 3. So press 3 here and matrix A you can see here. So here we need to do the inverse of it. So for inverse we have here that symbol, so we need to press this one, inverse. So it came again and bracket into minus of matrix B. So minus of matrix B, for go to shift and number 4. Here you can see the matrix B is at number 4, press for 4. So matrix B came, so close the bracket. Now solve it, our value will come. So our HC value is nothing but, minus 3.81, and VC value is nothing but 17.86, and MC value is nothing but minus 3.81. So write it here all the value. SC value is minus 3.81 and VC value is 17.86 and MC value is minus 3.81. So this is how we need to find the all the values by using the calci. So now the SC value we got was minus 3.81, so it is going like this. We need to take the, so left to right, if it's going we need to take the positive. It is going from right to left, then we need to take the minus. So it is going right to left, we need to take the negative like this. The symbol is like this, we need to take. and VC is going upward, and the moment it is rotating anti-clockwise means we need to take 3.81 like this. All the summation of fx is equal to 0, 0. So here horizontal is this. So HA, so HA minus, it is going this side. Now we need to take the minus 3.81 is equal to 0. So our HA will come out as 3.81 kilonewton. So HA is 3.81. So direction is correct, what we have taken, the direction is correct. Similarly, for summation of all the vertical forces is equal to 0, upward we need to take the positive. VA is going upward, so VA plus here VC is also going upward, so it has the value 17.86 minus, if we convert this usual to point load, it comes downward. So 10 into at a distance of 4, so 10 into 4 is equal to 0. So solve it, our VA will come out as 22.14 kilonewton. So it is also going upward. So whatever the direction we gave was right, 22.4. And the moment about point A, clockwise we need to take the positive. So clockwise we need to take the positive. So MA is, I will take as it is clockwise like this. So clockwise positive. So MA plus, if we convert the usual to point load, it also rotates the clockwise. So 10 into 4 into 4 divided by 2, because UDL always act at the distance of L divided by 2. L divided by 2 is nothing but our length divided by 2. Length is 4 meter. So 4 divided by 2. So plus 10 into 4 into 4 divided by 2. So plus 10 into 4 into 4 divided by 2 minus, it also act anti-clockwise. So 17.86, the perpendicular distance of this is the 4 meter. So this into 4 meter. So minus 17.86 into 4 meter. So minus the moment is anti-clockwise. So minus 3.81 minus here 1. Horizontal load is acting. It is also anti-clockwise. So minus 3.81. The perpendicular distance of this one is this. So 3 meter. So minus 3.81 into 3. Minus 3.81 into 3 is equal to 0. So calculate this. Our MA will come out as 6.68 kilonewton into meter. So clockwise. So whatever the direction we have taken, the clockwise is correct. So 6.68. And here the VA value is 22.14. 22.14. So make it 22.14. So this is how we need to find the other reactions. So if you like the video, like it, share it and subscribe for the more videos. Thank you for watching.